we on? Yes. Marvellous. That was amazing. That was a fantastic. I feel like I'm the smallest brain in this place. I don't often hang out with healthcare people, pharmaceutical people. It feels like this whole, most of my world is in finance, in banks. And basically in banks, what you do is you take a bunch of data from here, you pull it out, you munge it around a bit, and you put it in a system over there. And they call that finance. And you guys save people's lives and things, which is very different. So, okay, yes, I'm doing 2 talks today. I was going to do 1 talk, and they said, you can have a hoodie with your name on it. And so then I said, all right, I'll do 2 talks. That sounds cool. I want to talk about complexity. Complexity is everywhere in our lives. Complexity is hiding in plain sight. In fact, it's already hiding in this talk, because this talk is called Kicking the Complexity Habit, okay? So from that, you can already assume that it's about complexity, so maybe there's too many words there. So this idea of kicking a habit is a kind of reference to a drug type, an addiction type thing. So really, I could say the same thing just by saying kicking complexity, you see? So there was already too much stuff there, but we're used to seeing too much stuff, so no one noticed. And in fact, really, kicking complexity, that's still, okay, it's a bit of a play on words and things, but we don't really need that, because all I really need to say is complexity. And you don't need to know my name's Dan North, because you can find me on Twitter and it'll tell you. Yeah. So we're surrounded by complexity, and it's hiding there in plain sight a lot of the time. So there's a thing that I say a lot of the time. Apparently my wife tells me this, that I say this a lot of the time. I get really kind of frustrated with things, and I say, it really shouldn't be this difficult, okay? I say it really shouldn't be this difficult every time I put in a USB plug, okay? There are, in fact, 3 positions for a USB plug. There's the first one that doesn't work, then you turn it over and the second one doesn't work, even worse, and you realize it was right the first time, and then you put it back, okay? So USB plugs are the only physical device that has a superposition, right? So there are 3 modes for a USB plug. Deleting a folder in Windows, right, should just be delete. And it says, no, something is still using this. No, it isn't. I just rebooted the machine. Something is still using this folder. I don't care. I don't want the stuff that's in it. Make it go away. Okay, so we have complexity there. Things really shouldn't be this difficult. And then conversely, every now and then I come across something and I smile, and it makes me happy. And I say things like, someone really thought about this. Right? Someone really thought about this. Anyone here use Python as a language? Hacking on Python, right? Does it make you smile when you use it? It's just a joyful language. And I look at Python, I think, I use lots of other languages. I use Java, whoa, and then I use Python, and it just makes me smile. And Go has a similar thing. Anyone using Google's Go language? It's a very similar thing. It's very consistent. Someone's thought about it. Someone spent a lot of time thinking about stuff to make my life easier, and I value that. So I want to talk about complexity, and I want to talk about understanding complexity. So we need to know our enemy, right? So we want to look at 3 different things this morning. I want to look at identifying complexity. How can you spot it in the wild, yeah? I want to look at reducing complexity. So once we've identified it, what can we do to make it less? And then I want to look at avoiding it in the first place, okay? So we've got identifying it, recognizing, knowing your enemy, reducing it once you see it, and then see if we can avoid it altogether. So let's take a look then. Let's take a look at identifying complexity. So I want to introduce you to someone here. This guy his name's James Lewis. I don't know if any of you have come across James Lewis. I think he's a principal consultant or so. He's got a really fancy title now. He works at ThoughtWorks. I used to work at ThoughtWorks many years ago. A software company. They're now a global software company. They were in the US and the UK at the time, and India, and now they're all over the place. There's thousands of them. But James, I've known James a long time, and he has my favorite complexity metric. So his complexity metric is this. He says, so there's a couple of things about James. The first thing is he's Welsh. Okay, that doesn't matter, but it means he says things in a funny way. The second thing about James is he has an unusually large head. Okay, like physically quite a big head. And so his metric is this. He doesn't like software that's bigger than his head. Okay? And that's quite a useful, I mean, what I suggest we do is cut his head off and put it in a fridge in Paris and make it an ISO unit. Okay, but basically it's a unit of complexity. What he's talking about is he doesn't like to look at any code that's bigger than, that's probably about a 24-inch screen, right? So anything that's bigger than about a screen of stuff he's not a fan of. So here's an example. This is some code. In fact, this photo, this is any of you using Sublime Text, lovely little text editor on the Mac. This is all of the code in Sublime Text, at least at one point in time it was. It's a very neat little editor. And so as you can see, this fits in James's head. So that's okay, that's allowed, yeah? And so we're looking at this code. Obviously, this is not a real metric, right? But the point is it's a metaphor. So what we're saying here is this, is you can only reason about things that fit in your head. Okay, we've just been hearing about some things that completely don't fit in anyone's head and are unlikely ever to fit in anyone's head. So you can only reason about things that fit in your head. The converse of that is this. If something doesn't fit in your head, you can't reason about it. So if you can't reason about it, what can you do? What can we do instead? So, of course, this isn't really telling because all I've looked at is one dimension here because actually you've got a bunch of screens going on there. So none of this would fit in James's head. So that's a bit unfair. So what do we do then? What do we do instead? Well, what we do is we do what we know. Okay? We fall back on patterns we know. And systems thinking has a name for this. Systems thinking, or systems dynamics, started in the 70s, MIT University in the States. And they have a bunch of what we would call patterns, they call archetypes. And so there's an archetype in systems thinking called shifting the burden. And the full name is shifting the burden to the intervener, but that's all complicated words, so I'm going to explain what it means. Shifting the burden is this. It says we start with something like back pain, okay? So given I have back pain, what kinds of things do I do? It's a question, so you can say things now. What do I do if I have back pain? Massage, nice.
Swimming.
Pardon? Swimming. Painkillers, there we go. I go for my painkillers, right? So what I do is like, oh, my back's sore, I'm going to take some drugs. Yeah, Dan's little helpers, right? And so those drugs, then, they reduce my back pain, okay? Or really, actually, they don't reduce my back pain, they reduce my awareness of my back pain. But we'll come to that in a bit. And this is a loop. And so because this is a loop, there's feedback. And so systems thinking is full of these feedback loops. Okay, so, and this is a particular type of loop. It's called a balancing loop, so you put a little B in the middle. And that balancing loop means that over to if I take more painkillers, I get less back pain, and so on. And so it sort of balances itself out. However, it's not really sustainable, is it? Because what happens if I take painkillers over time? I build a tolerance to the painkillers. Yeah? And so that means that they're less effective. So there's some other things I could do. We talked about massage and exercise and those things. So let's take a look at these. I could manage my pain. I could exercise, I could look at diet, I could look at posture, I could do all these kind of things, right? And all of that's great, and then that means that resolves my back injuries over time, which is the right thing to do, okay? And again, this is another balancing loop, which is great. So why do we reach for the painkillers? It's simple. It's easy. What? It's fast. It's fast. And this is the point. So if we look at our bottom loop, okay, there's a delay in it. Okay, this is how you signify delay in a systems diagram, which is why I like systems diagrams. They're super simple. Okay, so I've got two loops. One of those loops has delay in it. As soon as a loop has delay in it, as soon as a feedback loop has delay in it, it has uncertainty in it. Okay, it makes me nervous. And so as soon as I have uncertainty, then I want to fall back on things I know. Okay? So let's take another look then. Let's look at another system that's very similar. Say I've got frustration or confusion is the presenting symptom of me looking at some computer system. Okay? So I look at this and I go, oh, I can't understand this software. It's too complicated. This code's a mess. And so what does that do? Again, I reach for my painkillers. This time my painkillers are workarounds. Okay? So it triggers workarounds. And I hack around things. I don't want to have to understand something, so I kind of try and contain it. Okay? And of course, if I hack on it for long enough, then it reduces, again, it reduces my frustration and my confusion. It doesn't reduce any of the complexity, but it reduces my sense of anxiety, if you like. Again, what's the thing I should be doing? Well, the thing I should be doing is I should be managing practices. Okay, I should be thinking about what the code looks like. I should be thinking about design. I should be thinking about all those kind of things. Okay, and then what that's going to do is that's going to reduce my application complexity, which was the underlying cause, after all. Yeah, but guess what? That has a delay. And so because the process of simplifying things and the process of breaking things down and the process of gradually doing that work to clean up my code base and to clean up my world has delays in it and has uncertainty in it, I fall back on the things I know. Here's where it gets tricky. Who in this room is a developer of some sort? Put your hands up. Okay, lots and lots and lots of you. Who are managers of developers? Okay, a few of you. Analysts? Yeah, okay, a few hands go up. Testers? A few other hands go up. Brilliant. Who haven't I called out? Which other people are here? Call out what you do. What sort of things do you do? That means I've got everyone or no one speaking. Okay, one of those two things is true. Okay, so these painkillers are everywhere. So what I want to do is briefly look at some of the places that we see painkillers. We see painkillers in architecture, we see them in design, we see them in our tools, we see them in our techniques, we see painkillers in our processes, and we see painkillers across our organization. Okay, so I just want to unpack some of these. Where do we see painkillers in architecture? Well, one of the most common things I see as painkillers in architecture are when we get these enterprise mandates. Someone says, your application will look like this. I don't want to process complexity of what applications look like. I don't want to think about design at scale, so I will have my one boilerplate design for everything. In the early 2000s, late 90s, early 2000s, we had enterprise Java, and every single application looked like enterprise Java. So what happened was Sun, who brought out Java, and they owned Java at the time, they proposed a bunch of things, and they called it the Enterprise Java Blueprints. Okay, and they had things like servlets and EJBs and JNDI and JDBC and all of this stuff. And it was it was layers and layers and layers. So it made a fantastic diagram. And what happened, the idea was it was supposed to be like a market stall. So you kind of pull the bits of it that you need, and then you build your application. But because they called it blueprints, a bunch of enterprise architects went, right, well, you need all the things. And so they just shoved all the things into every application, which meant that it was incredibly slow and painful and stuff to build any software. Nowadays, I see things like, I hear the phrase, we have an investment in. Whenever I hear the phrase, we have an investment in, I shudder. You know, well, you have to use a Oracle database portal server enterprise engine thing. Like, why? We have an investment in it, right? What that means is someone really senior dropped hundreds of millions of dollars on some piece of rubbish, and the more teams they can inflict it on, the more that it divides by, and so the cost per use goes down. Yeah, so what I want to do is find any poor, unsuspecting project. Here, you have this thing, right? There we go. That's one more, check, yeah? And so now what we have is a completely inappropriate solution being imposed on everybody because enterprise architecture. Okay, I'm not saying enterprise architecture is a bad thing. It's a very, very powerful thing. Enterprise mandates in this way are really, really dangerous. What about design then? So design, one of the things I see a lot, I consult in a lot of different organizations, and I see these undirected local choices. What does that mean? That means I've got teams or maybe even whole groups of people. I work in some organizations, I'm working in, there's tens of thousands of developers. I don't know why anyone would need tens of thousands of developers to run a bank, but hey, there you go. But what happens is all across the organization, this is like the opposite of enterprise mandates, is no mandates. Yeah? So now each team is making its own choices, and they're making good local choices, which is fine, but there's no direction there, there's no structure there. And so what that means is you end up with massive fragmentation, massive complexity, just because. Right? So again, let's choose a database. Well, this team's going to go with Oracle, because we've got Oracle. This team's going to go with SQL Server. This team's going to go with MySQL. These guys are going to use Cassandra. These guys over here are going to use Mongo, because they don't care about their data. And so you're going to find lots and lots of different choices all over the place just because. And now someone downstream of that has to manage that entire estate, and that's really, really complicated, and that's unnecessarily complicated. So tools then, this is really subtle, because all the tools that we use, typically, I'd say the majority of tools we use are designed to help us pretend we don't have complexity rather than to help us reduce complexity. I want to give you 2 examples, and hopefully the examples will make you go, because if they make you go, then it means you're going to start to be a bit more critical about the things you're using. So the first example I want to talk about is IDEs. Okay? So anyone here, who are the Java people here? Java, okay? And the C# people. Okay, so everyone else, go and hug the C# people and the Java people when you see them in the breaks, okay? They have a really, really tough time. Who are the Python people? There you go. Go and hug the Java people, okay? So IDEs are a way of managing complexity. I read a blog post some years ago, and I can't find it. I wish I could find it again, because I want to cite it. But his thesis was this. He says, the complexity of an IDE is a projection of the crapness of the underlying language. I was like, what do you mean? And so, well, so take IntelliJ, right? IntelliJ, wonderful, wonderful editor, brilliant, brilliant IDE. Has to be because Java is such a ridiculous language. I'm saying this as someone who's been using Java since '97. Okay, it was the first time I used Java. So, wow, 20 years. That can't be right. That's right. Gosh. So I've been using Java for 20 years. Someone decided when they designed Java that they'd do this. They'd say, if you change the name of a class in Java, you also have to change the name of the file that the code is in. So the file and the class name are coupled, which might make sense on a whiteboard or if you're smoking something. Okay? What it means in real life is this. If I want to rename a class in Java, then what I have to do is create a new file with the new class name, copy all the contents across into it, mostly, because I've got to change a few words, delete the original thing, go and find all the places the old name was being used and make that the new name, and I have to make that look atomic. Okay? Now, it gets more complicated when you change a package name. So package name in Java is tightly coupled to the directory structure. So that means if I rename a package in Java, I have to now create an arbitrarily complex nested directory structure alongside the existing one, but with slightly different names. I then have to recursively copy all of the files from the old place to the new place, changing some of the words on the way through. I then have to recursively delete the old thing. Blimey, I only wanted to rename a package. Then I have to go and find all the places. No wonder you need an IDE. You cannot do this in Vim. You'll die, right? There isn't enough time in the world to do that, to rename a package. And then, of course, refactoring caught on, and then we decided we refactor all the time. And so we end up with these incredibly complicated behind-the-scenes work that we need to do for what are mentally, logically very simple things. Renaming something because you have a better name is something that happens all the time in software. And we designed a language that's like the enterprise language that makes that arbitrarily hard. Yeah? So our IDEs are doing a huge amount of heavy lifting in order for us to be able to use these very complicated languages. Another thing I've noticed with IDEs as well, and I'm just as guilty of this as anyone else, is I get a new code base, I don't understand the code base, I don't understand where everything is, I just slurp it all into my IDE. And I slurp it into my IDE, which does huge amounts of calculations, and then I can start navigating the code. I don't need to know where things are to be able to navigate the code. And because I don't need to know where things are, I don't need to clean things up. And because I don't need to clean things up, the next person doesn't need to clean things up, and guess what? Things never get cleaned up. Okay? And we end up with these massive, sprawling, horrific code bases, and everyone's surprised. We don't know where these things came from. Okay, let's take another look at another one of my favorite things in software, which is I'm a build monkey. I love build engineering, release engineering. Back in 2006, I wrote a paper called the deployment production line. Woo! So we were talking about build pipelines and all that kind of stuff over a decade ago. And so when I think of build automation, build scripts is another fine place for hiding complexity. So what happens is when I first start out, I have a really simple build, and I code it in. And I have a build script, and I can run it. And then I think of another thing, and I put that in the build script. And eventually, the build script becomes the rug under which you sweep all of the crap. And you get this bigger and bigger and bigger and bigger. And now the build's taking 2 hours, and no one knows why, right? And the build takes 2 hours because once it took 30 seconds, and then it took 35 seconds, and then it took a minute, and then it took 2 minutes. And by the time it takes 10 minutes, no one cares if it takes 11 minutes. And by the time it takes 15 minutes, people are kind of okay with 17 minutes, and suddenly it's 2 hours, right? And then when you go and look at that build script, or that build system you have now, and you say, why are we even doing that thing? Why is that thing even still there? We don't know. It's just in the build. And so one of the things I try to do from time to time is delete the build. Go back and manually recreate all the things I want to deploy and start again. Start over with the build. But yeah, so build scripts, IDEs, just spend some time, not today, because today's going to be a day of filling your brain with new stuff, but when you get back to work, think about all of the stuff that's hiding in plain sight all around you that are these development tools, painkillers, that we use just to make our lives easier, rather than addressing the underlying problem. Now, I'm not saying these things are bad, in the same way that painkillers aren't bad, but painkillers aren't the solution. Painkillers are the things that clear your mind enough that you can start to solve. Right? If I have really serious back pain, I want some painkillers so that it relieves the pain enough and reduces the swelling so that I can start exercising and doing all those good things. If I don't do all those good things, I end up dependent on the painkillers. And in fact, that archetype, the shifting the burden archetype, is also known as addiction. It's the same way you model addiction. So we looked at tools. Let's look at some techniques now. Test-driven development. Who does TDD? Who are the TDD people? Yeah, lots of you. Oh, he's going to have a go at TDD. I can't believe he's going to be mean about TDD. No, it's okay. I love TDD. I'm a huge fan of TDD. What I want to talk about, though, is mocks. Mock objects. Who uses mocks in their TDD? Oh, a few hands. Okay, yeah. I mea culpa, right? I was one of the huge advocates of mocks in the mid-2000s. And the idea is, with a mock object, is that you start at the edges of your system, and you build inwards, okay, and you fake out all of the insides until you get there. So that's the point of a mock object. Unfortunately, what happens is people start using mock objects in existing systems. And what they do is they use mock objects to fake out parts of the system they don't understand. So I have this huge code base, and I want to change this little thing here, but this little thing here is coupled to all of these things over here, which makes it really hard to reason about. So rather than doing the right thing, which is breaking all of that coupling, right, and starting to isolate this thing, that's hard work. And I'm busy, and I'm in a hurry, and I've got a product owner who's shouting at me for stuff and features and story points and all that other shenanigans. And so I don't do that. What I do is I slot in a few mocks and fake out the whole rest of the system so I can reason about this thing, which makes sense tactically. Strategically, it's a really dumb thing to do, because it means we never really address the underlying question of why did we need those mocks in the first place. If you're mocking out things that don't exist yet, great, go nuts. If you're mocking out things that do exist, ask yourself why. Okay? That's probably some coupling in a system that you could do some work to decouple. And you won't do it overnight. You'll chip away at it and chip away at it. Okay. Process is an interesting one, because I've seen organizations swing from massive amounts of process to no process at all. And I would argue that both of those are really dangerous painkillers. Okay? So having huge amounts of process, we were just talking about the regulatory environment where it takes 8 years before you're even allowed to try this thing on humans. Now, I don't know why it's 8 years. I can guess that it used to be no years and people would die, right? And then they said, well, we should try it for at least a year. They said, okay, then great. Well, okay, let's try it for a year. And they tried it for a year, and they said, now we can try it on people. And then fewer people died, or there were fewer bad situations. And so they gradually upped the time until it got to 8 years. And at 8 years, it went below a threshold that someone decided that was okay. And so now it's 8 years. This is typical process thinking, right? This is typical looking at the wrong end of the stick. So rather than saying, okay, if after a year there's still this huge amounts of complications going on, let's make it a second year. We don't. What we should do is say, well, if after a year we're still getting all these complications, what in the process is true such that that's happening? How could we change the process such that that's less likely to happen? So I don't know in terms of safety critical things, in terms of healthcare things, in terms of things that affect people's lives, but I do know in terms of systems that don't. And I've seen this. So I had a particular client, and they have a 4-week test window for every release. If I change one line, there's a 4-week test window. And I questioned this. I said, why is there a 4-week test window? And they said, well, it used to be 3 weeks. But then too many bugs got into production, so we made it 4 weeks. I said, what was it before 3 weeks? 2 weeks. And before 2 weeks, just a week, right? And so what happened is they lengthened and lengthened the testing phase because bugs were getting into production. And I said, okay, so let's just follow this logically. Eventually, it'll take 6 months, right? We'll add 20-something weeks because we're terrified of these bugs getting into production. Why not change the system? What is true of the system of work such that these bugs are still getting into production? Let's go and look at where the bugs are coming from. Let's see if we can change how we do work. We know we're not bottlenecked at development, we're bottlenecked at testing. So if we did more development, if we changed the way we build code such that entire classes of testing became redundant, we would be a lot more confident about the code going down the pipe. That's more development work, but we've got development capacity, we've got development time, we don't have testing time. And so, meanwhile, the developers are all getting all agiled up and they're very excited about agile, agile, agile. So they said, right, we should just stop doing all this 4 weeks of testing and we want to make it, 1 week of testing. I said, no, you don't get to do that. Oh, yeah, I'm supposed to be the agile guy, right? They said, no, you don't get to do that. And they said, why not? I said, you have to earn that. So what we're going to do is this. For the next several releases, we're going to get our house in order. And for the next several releases, they will find no defects in week 4. And once they've found no defects in week 4 for several releases, we're now allowed to go to 3 weeks. And then once they've found no defects in week 3 for several releases, we're allowed. So we have to earn the right to go down, down, down. Okay. Now, I imagine that's a lot harder in healthcare because you can't say, well, let's just put some of these out after 7 years and see what happens. Right? Oh, okay, someone died. Sorry. Yeah. So the risk of failure or the impact of failure is much, much higher in that situation. But whenever I see a long period of time, my instinct now is I bet that's made up of lots of little periods of time that gradually got longer and longer, right? Because we're not looking at the underlying system of work to say what's true such that this bad thing happened. Likewise, flipping it the other way and throwing all the process away, that process usually comes from good ideas and usually comes from a desire for some kind of oversight. And again, Kent Beck recently tweeted this as a lovely phrase. He says, autonomy without accountability is just vacation, right? Which I really like. Yeah? Have autonomy, right? You are on the hook. If you want autonomy, you are accountable. And suddenly people go, oh, I'm not so sure about all that autonomy you're offering me. Yeah? So be aware that it comes with a cost. And then finally, the organizational complexity then. Who's heard of Conway's Law? A few hands. Okay, a guy called Melvin Conway. This is in 1967. I literally wasn't born yet. I was born fairly shortly after that, but I wasn't born in 1967. He made an observation, and it's still true today. He said, the architecture of any computer system reflects the communication of the organization that built it. Okay, so let me say that again. The architecture of a computer system, or typically a large computer system, is a reflection of the communication channels in the organization that built it. So if I have a big, hierarchical, low-trust organization, then I'm likely to end up with big, hierarchical, low-trust systems. If I have a team of front office, say in a bank, I've got front office, middle office, back office software teams, I'll get systems that have front office systems, middle office systems, and back office systems. If I'm trying to get work to flow all the way through all of those, there has to be all the handoffs between the different layers. Hence, most of my life is get some data, do stuff, emit some data. Okay? So what we have is software systems that project the organization's shape. And so what we need to do is now reshape the organization so they will inevitably produce the architecture of systems we want. It's called the reverse Conway maneuver. Okay? So Spotify famously did that. They said, what shape do we need to build the sorts of platforms and systems that we know will be sustainable? And so they restructured themselves around their software architecture. Amazon did this in 2003, 2002. They said, we will structure ourselves as a series of small service providers. And Jeff Bezos sent a famous email. He says, every single department, every single team will only talk to other teams through their APIs. If you want to book a vacation, you do it through the HR system's APIs. If you need to do something else, you need to ask the HR system to add that to their API. You're not allowed to go into anyone else's databases. You're not allowed to go and directly ask people things. You have to talk to their API, to their organizational API. And that happened over many years. And then in mid-2000s, he took the way that Amazon staff get servers, and he just opened that out to the world, and he called it Amazon Web Services, and made a multi-billion-dollar industry practically overnight, which is pretty cool. So what he said was every team that builds a service, it needs to be fully documented. It needs to be externalizable. He said, so I reserve the right to take any service, including that holiday booking service, and open it up to the public internet at any point, which means you have to think about security, availability, resilience, authentication, failover. You need to think about audit. You know, all of those things that we typically don't think about in trivial internal systems became a thing. And so that meant that then when he created S3 and EC2 and all these Amazon Web Services and now recently Lambda and all that kind of stuff, which I'm playing with at the moment, it's awesome. Go serverless. He exposed all those things to the world. All he's doing is monetizing the way that people inside Amazon get work done anyway, which is kind of cool. Right, so you can use Conway's law as a lever. So, okay, so this is recognizing complexity. What can we do to reduce it? Let's take a look at reducing complexity. There's a number of things we can do. The first thing that you can do is a subjective thing. It's a personal thing. It's an in-your-head thing. And this is this. Monitor your own cognitive load. Right? Monitor how hard you are finding it to do things, and ask yourself the question, is the pain I'm feeling, is the amount of load I've got going in my head, is that proportionate to the kind of problem I'm solving? If I'm sitting there, I mean, there was a ThoughtWorks project some years ago now, where a small team, they worked with a startup, and they were modeling, funny enough, cancers. And they were looking at tons and tons, huge amounts of patient data, and they concluded exactly what you were talking about, Pavel, was that when you talk about lung cancer or heart cancer or bone cancer, the place in the body the cancer appears, it turns out, doesn't matter, largely. Right? It's the type of cancer and the types of different, a single presenting thing might be several different types of cancer all at the same time. And so what he was trying to do was build a system that was going to provide a doctor in each individual patient situation a way of choosing which of, say I've got half a dozen different things I could use, I don't know which one's going to be most effective for this particular person. And so this system would help them make that as a decision support system. Right, my brain exploded when this guy was describing this to me. I was thinking, that's hard, right? That's a necessarily hard problem. I expect him to be sitting there really scratching his head, and he's a very, very smart guy. I tried to get my printer to talk to my computer. That is not a hard problem, okay? I am currently writing a really trivial web app for my father-in-law, okay? And I'm okay at writing software. I've been doing it for 25 years. I think I've got the hang of it quite a lot. And I was going back to web applications for the first time in a couple of years. I couldn't get a submit button to work. Right? Idiot. Idiot, or it's really complicated. It turns out that in different browsers, the behavior of a submit button in an HTML form is different. If you hit enter in some browsers, the submit button gets triggered. Okay, but it doesn't submit. It just triggers an event on the submit button. In other browsers, it does submit. In some browsers, it depends whether you have a text area on the same page as the submit button. Because reasons. Yeah, I lost hours of my life to this pointless thing. Yeah, this is disproportionate cognitive load. Monitor your cognitive load. If the thing you're doing, if you're there, that thing like that, my opening line, it doesn't need to be this hard. It really shouldn't be this hard. If it really shouldn't be this hard, do the work to make it less hard. Try and make it less hard for the next person along. This is hard. This next one's hard. Seeing what's really there is really hard. Okay, so I'll give you an example. A friend of mine was working on Java, and a lot of my examples are Java. And he wanted a web server. I said, oh, there's loads of web servers. He said, no, Dan, there aren't. There's loads and loads of servlet containers, but there's very few web servers. There's almost nothing that just does HTML or HTTP in Java. There basically isn't. Everything has this massively complicated enterprise Java baggage with it. And so he went off and wrote one. Like there aren't enough web servers in the world. But the thing is, there wasn't a decent Java, just a web server. And he saw what was really there. I thought I was looking at a web server. He knew he was looking at a servlet container, which had way too much complexity. Next thing, use consistent idioms. Okay, so if particularly in languages that have lots of different ways of doing things, or technologies that have lots of different ways of doing things, have opinions. Be opinionated. Okay. So what that means is that then when you go back and look at things over time, you can reason about them. If you don't have those opinions, you'll get all of that local fragmentation I was talking about. And be aware that familiarity and simplicity are different things. What do I mean? So familiarity is this. If you've been using Microsoft Office for many, many years, okay, you know that file page setup is where page setup is. Yeah? The problem is page setup has nothing to do with storage of data on a disk. It has everything to do with formatting. There's a format menu, but page setup is still under file. Microsoft tried to move it under format a few years ago, and there was such an outcry they moved it back, right? Because people are familiar with it. So familiarity is when your brain gets bent out of shape in order to use a broken system. Simplicity is when the system fits in your head. Okay? Unfortunately, when you're inside the system, they both feel the same. So you become used to something that's really broken and you think it's simple. It's not, you're just familiar with it. So the test I use is this, is when the next person joins the team, I say, hey, welcome to the team. What's the dumbest thing you can see us doing? So what do you mean? And it's a deliberate question because it suggests there's a non-zero number of dumb things, right? And you have permission to tell me because you just joined the team and you're on your best behavior. You don't want to upset anyone. I'm saying, please upset us. Tell us the dumb thing. Yeah? So get them before they become institutionalized. Here's a quick example. This is two cities. This top one here is, oh, there we go. New toy, hang on. There we go, right. So this is London. This is central London. This road here, that road here, is called Holborn. It's also called Holborn. It's called Cheapside. It's called High Holborn. That really confuses Americans. They hate that. So the same road changes its name 3 times in less than a mile. Okay. In the States, this is Chicago. Oops. That's not Chicago. This is Chicago. This road here is West Roosevelt Boulevard, okay? West Roosevelt. West Roosevelt goes from here, across here. It's still West Boulevard. This is about 10 miles. It carries on. I reckon it's probably still West Boulevard when it gets to Japan, right? But the thing is, it's gridded. It's designed as a grid. It's a whole load of very rectangular. London isn't like that. Okay, and the reason is that Chicago was designed and London just sort of happened, right? But of course, if you look at The Tale of Two Cities is a reference to a book title. The real other city is Paris. So it's about London and Paris. And this is a city that wasn't designed either. It just kind of happened. Who's been to Paris? A few hands, right. So Paris, this is a map of what's called the Arrondissements in Paris. So those are like the little kind of districts of central Paris. And they're arranged, which I think is rather cool, they're arranged like a spiral, okay? So they call it the escargot, the snail, yeah? And this was designed by a chap just post-revolution, so in the 18th century. And what he figured out was this, is if you design your boroughs in a circle, like that, in a spiral, it's really hard to get lost. Because every single street corner has on it the number of the arrondissement, the number of the borough. So it's the 18th or the 9th or the 3rd. And so you see a number and you go, 9, right, I'm in 9. You walk in any direction for a few minutes and you'll find another number. You'll get to the edge of that borough. And given those 2 numbers, you now know exactly where you are. Okay? It's really hard to get lost in a city that's designed like that. So what they did is they simplified what was already there. They said, we can't just refactor Paris. Flatten it and do grids, yeah? What can we do? What abstraction would make it would allow us to reason about Paris in a way that people can navigate the city? Really, really, really genius piece of civil engineering or social engineering. So okay, so that's that. This is about reducing complexity. How can we avoid it altogether? Okay, and this is really where this is my plea to you. Okay, this is my call to action. All right. Is complexity is the default state. So the fact that things are complicated, entropy increases, okay? So complexity is the default state. If you have 10 different teams and you give them no direction, you'll get 10 different solutions. You'll probably get 15 different solutions, okay? To the same kind of problem. So what we need to do is create that consistency across that piece. So there isn't a physics, but there really is a lot of local decisions, and those local decisions mean that that we're getting that fragmentation. Okay, so without a strategy, without a direction, without some leadership, without some communication, and that leadership doesn't have to be hierarchical, that leadership can be peer leadership across communities of practice, but we need to do something to set us up in the right direction. So be aware that complexity is a default state. Complexity grows one day at a time. So Fred Brooks, Professor Fred Brooks, who wrote the No Silver Bullet paper and also wrote The Mythical Man Month, which is a fantastic book that you should go and read. He was given a massive toxic project by the US Department of Defense, and he gets hauled in front of this group at the Department of Defense, and they say, Professor Brooks, this project, well, there's hundreds of millions of dollars or whatever it is running, is 2 years late. How can a project possibly be 2 years late? And he says, oh, that's easy, one day at a time. Right? That's how a project becomes 2 years late, one day at a time. Yeah? So again, we can rein it in one day at a time. Okay? Consistency at scale, then, is a daily choice. Okay? It's a thing that we can choose to do. I can choose to go into work today, and I'm going to make a decision, and before I make that decision, I'm just going to check in with some of my peers to see if someone else has been down this road, which means that it's also our responsibility to make our decisions discoverable. What can we do internally in terms of systems, tools, processes, structures to make our decisions, to make our strategies, to make our direction of travel discoverable? Because if it's discoverable, people will go after it and people will use it. If it's not discoverable, even if they go looking for it, they're likely to end up fragmenting. Okay? And again, so that means we need to agree idioms, we need to agree guiding principles, we need ways of doing that. And ways of doing that that's a governing body of 5 people huddled in a room coming out and issuing edicts, right? That one doesn't work. Yeah? Some of the other ones work, that one doesn't work. Because as soon as those edicts don't work in my situation, I won't tell you, I'll just work around you. I'll subvert you. Yeah? All the really good work gets done as skunkworks projects because it's so incredibly hard to get anything done around here. Yeah? I'm seeing some smiling, right? And we want to strive for simplicity. Okay, not that familiarity thing, simplicity. So when I look at something and I'm sensing that cognitive load, yeah, ask myself, is this useful cognitive load? Am I applying my brain because this is a brain applying problem, or am I actually learning something here? Am I contributing something here with my brain? Is this the right amount of mental pain to be feeling? Okay, strive for simplicity. And we want to choose tools and want to choose techniques that make it easier. So I can choose my language choices, my tool choices. Some tools are much more consistent than other tools. Some languages are much more consistent. Anyone who's been using Scala or Clojure, Scala is this massive, sprawling mess of a language, and Clojure is basically a pair of parentheses, right? And sort of somewhere, so in both of these languages are really good for different situations, but if you're using something as massive and unopinionated as Scala, you need to be very, very specific about which subset of it you're going to use in your team with this piece of work. And anyone onboarding, they need to learn that too, so that you can maintain that consistency over time. Okay then, so summing up. Complexity is the default condition. Right? Don't assume that because things start simple, they're going to stay simple, because they won't. Okay? Simplifying is always an option. It's harder than not simplifying. Right? Doing exercise is harder than popping a pill. Okay? But it pays off in the long term, and it pays off to you in the long term. Okay? And consistency is the key. Right? So as I say, it really shouldn't be this difficult. Right? So if you can get to the stage where you go, it really shouldn't be this difficult, and if instead you come into work one day and you look at the code base and you go, someone really thought about that, then you're winning. Thank you.